Hello everyone and welcome back. So now we'll be looking on how to perform basic static analysis on a malware. And basic static analysis is the easiest and the simplest malware analysis techniques you will ever use. And for that we mostly start with it, apart from using the malware on the sandbox if you have a ready sandbox. We will be using basic static analysis to understand some of the functionality about the malware. It is basically hunting for the hanging fruits, maybe some domains inside, some commands, some clues that gives us information about the functionality that is in the malware. This functionality we can investigate it further in the behavior analysis and in the code analysis. With these steps specifically, it makes our life easier when it comes to behavior analysis and code analysis, because it can tell us if it detects a sandbox. It can tell us if the malware detects a VMware or some malware analysis tools or Wireshark, or detects if it's being loaded in a specific way or needs a command line. Some of this information might be visible through basic static analysis, as well as it can tell us some information about how the malware communicates with the world. What are the functionality that we need to look at? Does it have a configuration? How it loads its configuration? And so on. And this information can be very, very helpful when we go into code analysis. So we will be talking mainly about binary-based type of files. Let's say exe file mainly, or that could also apply for Linux files, can apply for Mac files, can apply for documents. And there's two things we will be looking at. The first is the strings. Strings are text inside a binary file. For computer, strings are basically any text you see. We call them strings. And what we want to do here is that we have a binary file that includes so many random data, but we need to find any text inside that file to give us some clue about what's happening in that malware. You can, we will be seeing how to extract these strings from inside binary data in the demo very soon. And as well, you can use these techniques on a script, PHP script or PowerShell script. The whole code is text, but you can see some specific strings in between quotations that are being used they're being used somehow to communicate to the internet, like could be URLs, could be commands, could be PowerShell commands, or could be whatever. And we can extract this information to understand more about the malware behavior. So strings that we are looking at inside the malware, there might be so many strings we don't care about, but there are some things we're looking for. And if you have a malware, you have a big bunch of text inside of it, or if you have a memory dump or a process memory, a dump of a process memory, it might include so many texts you don't care about. But you need to search for or extract some specific information that can tell us a lot, can tell you a lot about what this malware is doing. The first thing is any link or any URL, domain, IP, a full URL that can tell you how this malware communicates, or how this malware communicates to the attacker. That this link could be not only a malicious website or an unknown IP. It could be a Twitter handle, it could be a YouTube channel, it could be a baseband link, could be whatever, but this can tell you a lot about how the malware communicates with the attacker. You could also see commands in the command prompt. Maybe these commands disable firewalls or collect some information like task list, process list, find, trying to find the Active Directory data, or whatever. It could be some configuration for the malware, and we have seen that multiple times. It could be registry entries that used to register some services or disable other services, or register entries to maintain persistence. Could be APIs, we'll look at that later, which is the Windows command. And Windows commands tell us a lot about the malware functionality. Let's say download file or download URL to file. This command, it's a known Windows command, is being used to download files from a URL, from a given link, and save it to a file on disk. So it downloads a file from the internet and save it in a specific path. URL download to file. There's others like copy file, delete file, move file, some strings about some paths like application data path or a temporary directory path, or whatever paths there are inside the malware. It could be as well something we call BDB strings. And BDB strings, it's a debug string. It's a string that mostly created by Visual Studio and being saved inside the file that you have compiled inside Visual Studio. If you are developing an application in Visual Studio, let's say with C++, after you compile it and you have the released the executable file, some of them, they include this text, this link basically, or this file path inside this executable strings. The reason for it is to have some debug strings and some debug information that you can easily debug this file later on. But anyway, we see these BDB strings inside so many different malware, and it can tell us a lot about what is this malware is being used for, what is the name of the user, some information that might be useful, how the actual attacker named his own malware, so we might see what that means, as well as it can help us connect different malware to the same attacker. So we have seen 3 or 4 different samples, and they all use very close or very similar BDB string. It's similar path, like C users 123 documents Visual Studio 2010 projects, but different name of the malware, and then release, and then the name of the BDB file. We can see very similar paths, and that can tell us, oh, probably all of these malware families have been compiled with the same user. They might be all related to the same attacker. So it can tell us a little bit about the malware, about who's behind the malware, if the user has a real name, or and can tell us about how he looked at the malware, how he names his malware, and so on. Other strings, something we call it the formatted strings. And formatted strings is basically a type of strings that takes kind of a wildcard, like this present, and then S, or percent, and then S. This means put any string here. It's a kind of a template of a text, and this template you can fill it with some information. Like this is a template of a text, date, 2 double dots, and then a number slash a number slash a number, and then you can fill it with the current date, you can fill it with tomorrow date, you can fill it with the next year date, whatever you want, with filling these parameters inside this template. So formatted strings, you can Google it more, you can pause the video and Google it more, but basically it is template strings that you can fill it with some information. For the first one, get, and then put any string here. Let's put any page name, let's say index.php, index.html, CGI-bin / login.php, whatever you want, and then HTTP1/1. And this is mostly used, this string is mostly used to request a page from a website. And you can see here, this is the string, and this here, or this is the template, and this is here what you will fill inside the template. So here he took that template, get, and then text, and then HTTP1/1, and then he filled that text area with the /index.php. The result will be get /index.php, then HTTP1/1. So this will be the template after we fill it with parameters. These formatted strings, you can see them a lot inside malware, and it can tell you a lot about what this malware is basically doing. Maybe you can find mutex names. Maybe you will find process names that the malware is trying to inject inside, or tools he's trying to process, he's trying to detect, who represents virtual machines or represents antivirus applications or represents malware analysis tools that he's trying to detect, terminate them, or terminate itself if he sees them. File paths that reveals some of the functionality, sometimes passwords. We see some malware that exfiltrate data to Dropbox, and inside the strings we see the username and password for that Dropbox, and as well the Dropbox link. So with just looking at the strings, we can already see all his exfiltrated data, and we can actually stop this attack by reporting that account to Dropbox to terminate it. We can collect logs on who's actually accessing that Dropbox account from Dropbox company, and we can actually do lots of investigation on the attacker just by finding these strings inside the malware. And we did see cases like that. Maybe we can find public key for encryption. Maybe we can find PowerShell commands and so many different things. Now, this is basically about the strings. We will look at demo on how we can perform strings investigation, strings harvesting, basic static analysis using strings. We will have a small demo on actually a malicious document by an Iranian group that's used in a targeted attack. We'll look at this document from strings point of view. We'll be able to extract different strings, see the commands, see the CNC, see lots of PowerShell commands, see lots of information. So see you in the demo now. Bye bye.